Okay, here's part 2 of the solution to sac217 number 4. Essentially all we've got to do is copy all this stuff into a spreadsheet. So I'll start off with the delta t. I'm calling that 0.123451 seconds to start with. I'm going to go ahead and label that. I'll call it just dt. And then some of these other values I had mu 0. 4 pi times 10 to the minus 7th. So I go equals 4 times pi is pi, open close parentheses, and then times 1e minus 7 means times 1 times 10 to the minus 7. And I'm calling that mu sub 0. So mu sub 0. What else do I have here as far as values that I need? 12 amps was I. Capital I. And 3.05 times 10 to the minus 3 coulombs for Q. E minus 3, I think it was. 3.05 times 10 to the minus 3. Yeah. And then 8.93 times 10 to the minus 10. E minus 10 for the mass of the object. And I'll move down here in case I need a little extra room. But start copying these headers across. N, T, X, V, V, and then B before the A's. So N, T sub N, X sub N, Y sub N, Vx sub n, I'll call it V sub x sub n, but Vx sub n is good. Vy sub n, and then we had a B sub n, and then Ax sub n, and Ay sub n, and then we went to the halves. So do this part of the table. Just did a y, I didn't need the x, and then the two v's, the b's, and the a's. So y sub n plus a half, and I'm going to try just copy this thing. Okay, so then it was the V's, so Vx, Vy, then I think there was just a B, and then Ax, Ay, oops, A. I think that's it. I don't get too many of those there. So check and make sure. Ayn plus a half was the last thing. Okay, get back over to the start. I gotta I'll call that 0, and then this is equal to the previous value. I'll just click on it, plus 1. Okay, then the t is equal to the n times, I need this value right here, but I want it with $, so I'll call it $A, $1. And I'm going to actually copy that, so I'll do Control C, because I think I'm going to need that a lot. Okay. Let's work on X. Yeah, I think I'll do it column by column. So that one just gets copied down. X sub n, it's, I remember it's just 0, the original one. And then the next one, it's equal to the one before it, which is this thing, plus, and now it's the one at the half interval, so it's the one before it, the velocity, Vx, will be that thing right there, times delta t, which I can just hit Control V to get that $A, $1 in there. Okay, so we got nothing in that V spot up there, and hence I would expect that to come out as a 0. Okay, this, I want to try just copying these guys over there. I'd say that didn't work. I see, that one jacked this up by 1, but y sub n was actually equal to 0.01, was up there at a centimeter, and then I'm saying plus L8, which is, what's an L8? Vy at n plus a half, the middle of the time interval from here to here, times delta t. So that actually worked. The initial x velocity was 12 meters per second. I remember it was moving to the right, the particle moving to the right at 12 meters per second. Initial y is 0. And then this had to be equal to the velocity before it plus the acceleration at the half time interval. So it's equal to this plus the acceleration at the half-time interval, but in the line before it. And I'm working on the x, so it would be that. And then times the $A, $1. Okay. And I think this might just be able to copy that right over. So it's should be saying it's equal to F8, the thing right before it, plus O8, which is the AY at the half interval, times delta t, which is what I got in A1, this value right here. Okay, that looks good. Bn, I gotta look at that. Bn mu 0 over 2 pi times I over y sub n. So equals mu 0, I'll call that $D, $4. Make sure I always get the right one. And then, I forget what it was. Mu 0 divided by 2 pi. So slash, I'm going to put the 2 pi in parentheses. 2 times pi, close parentheses. And then, so that whole fraction is multiplying I, which is this value right here. I'll put it in absolute addressing, so $D, $2. And then over y sub n, which is this value. Phew. Okay, and that one just gets copied down. It's just ditto marks here. And then the A just depends on the V. So the x component of A has a minus sign and it involves the y component of the velocity. Let's see how much of that I can remember. Q VB over M. So equals, there's a minus sign. Q, I'll call it $D, $3. times v, and I need the y component, so v y component, and then I think it was times b, that would be this, and now I've over m, so slash m, I don't know why I call that mu0, but it's this value right here, D4. $D $4 for the absolute addressing. Then I'll fix this title. And I don't think that'll work for, well, first off, this just gets copied down here. But because I get the X and the Y business in there, let's go ahead. I'll try copying it and then fixing it up. So it's there should be no minus sign in this one. So I'm actually looking right here. There's no minus sign, and instead of VY, I'm using VX. Other than that, quite similar. So this was my V. And it's the Vx is in column E. So E, and then times the B, and that B is in column G, and then all divided by the mass. So I think that's good. That gets copied down there. Okay, this makes sense. That times 0, it's got some acceleration, positive acceleration plus y direction, but no x acceleration, because the v cross b in this picture is straight up at this point. And at time 0, it's got a negative x component later on plus a y component, but starts off with no x component, just a y component, which is positive. Alrighty. The yn plus a half was yn, so the value over here, plus the v0 value over here, times delta t over 2. Delta t over 2, don't forget that. So this equals the y over here plus the Vy over here times $A$1/2. It's my delta t. Alright, did that just get copied down? No, that one is the one before it plus. So it is actually very similar. So I'll copy it down and then say it's the one before it, which is J8. Oh, and we're using the full time interval. So that corresponded to like going from 0.5 microseconds to 1.5 microseconds. I use the velocity F9, which is the velocity at 1 microsecond, midpoint of the interval, and then, okay, that would have been easier to type in from scratch. Vx, alright, this is the starting business again, so I'm using the velocity from this line, the acceleration from this line, and then times delta t over 2. So it's equal the Vx plus the acceleration from this line times $A$1/2. Okay, this one is equal to the one before it plus the acceleration for the halfway point in the time interval, which this is half a microsecond to 1.5, so it's the one at time 1. So the acceleration x component right here. Yeah. And then times the full delta t, $A$1. Alright, let's try this one. Equals Vy0 plus AX0 times $1/2, and then here equals previous value plus new acceleration times the full. So for Vy, I want to look at this one again. This is an F8 plus H8. That's good. For some reason I used the X component of the velocity, so that should be an I. I used the X component of the acceleration and I needed the Y component of the acceleration, so I think I fixed that up. Okay, and then Bn plus a half. Looks like the old B except Yn plus a half instead of Yn. So yeah, Control C, I'll just copy that over there. Control V, except for this last thing, that's this last thing right here, instead of J8, I need it to be, actually is J8. Yn plus a half. Just happened to be the same distance over as the previous case. I was using D8. That's 1, 2, 3 over from it. This one's using J8, which happens to be 1, 2, 3 over from it. Okay. And then for B, it just got copied down. Alright, the Xn plus a half, we're almost there. That's the minus QVY, QVB over M, but it's the Y component of the velocity and there's a minus sign. So it equals minus the Q is this guy up here, D3, so $D$3 times as a V, but I need the other components. I'm working on X. I need the Vy for the n plus a half, and then times the B, QVB over, I think it was M, which is $D$4. Alright, I think that's it. Let's check this. Yeah, it was over M. Okay, that looks good. Now this one, the same thing except I got X and no minus sign. So just say equals Q, which is $D$3. V, I'm working on Y and I want the X one. That didn't work out too well. Let's, I think what I'm going to do is copy this one over to here. Q, there's a minus sign in front that I don't want. Then I got the Q, I need a different V. I hit delete key there, and then just click on the V I want. So I want the X one. Yep, that pops out of there. And then times N8, which is supposed to be M8 for B. That's the B. And then over the mass. Alright. I think I got it. And I believe these are just copied down. That's good. So I'll take these two, copy them down one more row. And that's supposed to be good for row 2, and everything else is just copy it down. I'm going to try to make 1,000 of these. So, okay, gotta go to about 1,008, something like that. Try 1,007. That's 999, so I need one more. Should have gone with my original guess. If I want 1,000, which is arbitrarily chosen value anyway. Time seemed to be counting up. This A is not changing. It's not. Not a good thing, I don't think. But let's see what our trajectory looks like. So I'll plot y versus x. Let's see, this is the time. Here's the y right here. And let's put that in a little graph. Finish. Let's see what that looks like. Gotta get rid of that. Fix up the titles, but I know this is just my trajectory. I think what I want to do is put that square on there, so I'll put the, call it a box, and I'll let this be the x component of the box, and this box y component, so I tried drawing it around this way, from here to there, to there, to there. So this is supposed to be a box that measures 20 centimeters along the side. So this distance is 20 centimeters. So I'm over here 10 centimeters, which is 0.1 meters. So this position is minus 0.1 comma minus 0.1. I'm over 0.1 and I'm down 0.1. So minus 0.1, 0.1, and then I go up to the next corner up here. That would be, so minus 0.1 but plus 0.1 for the y value. Minus 0.1, 0.1, and then over here 0.1, 0.1. Then I go down to here, which is 0.1 minus 0.1. And then I'm back to the start. I'm down to here, so I go back to the start, which just do a Control C, Control V. Okay, so now I want to add some, I'm going to hit Escape to make those dotted lines go away. I'm going to add some data to this, source data, series. I'm going to try to add a series. I call it the box. And the x values, I'll just select them. Hit Enter. And y values, I'll select them.
hit enter, and something went wrong. So seem to have missed the initial x values. There's supposed to be -1 there. Let's cancel that. Yeah, I think I just forgot to type the minus sign there. So it's gone when I copied it as well. Alright, let's try that again. Chart, source data, add, box, choose x values, hit enter, choose y values, hit enter. That looks more like a square. Hit OK. And let's look at this graph. Okay, I gotta get rid of these grid lines. Hit delete. I think I'll try to make the plot area clear. Okay. Make that square look a little bit more like a square. Alright, that's looking pretty good. This is my curve right in there, so it's not going very far. Let's try making the time bigger. I'll take out one of these zeros. So it made it outside the box. It's just going straight to the right, it shows, which is consistent with my concern about this acceleration never changing. Let's see if we can figure out what the problem there is. So, okay, I found one mistake right here with the BN. I was using the mass instead of mu0. This should be a $D$1. It's this element right here. So I'll change that to a 1. Remember, I had that mass mislabeled. I think it. Go ahead and fix that label anyway. It changed it on me when I was typing it in. I wasn't looking at what I was typing. So, okay, so that gives me the $D$1, and I'll go ahead and copy that down. I'm going to do a Control-C, and then select the next one, go all the way to the bottom. I'm in column G. Do a Control-V. Okay, that should do it. Hit Escape. Make that dotted line go away. Then see if I get the same mistake with this other B. Yep, the $4 there should be a $1. And then I'll copy that guy. Control-C. Select that. Slide down to the bottom. Shift. Click on that last one and do a Control-V. And hit Escape. And let's see if things are changing. Looks like this needs to get a little wider so I can see the numbers there. But yeah, the AY acceleration is changing. The Y value is changed. And there goes an unusual curve there. I want to check, make another check. If the thing is, with a charged particle in a magnetic field, the magnetic field always pushes the charged particle sideways, so there's never any component of the force along the velocity. It's always at right angles to the velocity. You can tell just by looking at this formula. So
it never does any work on it, and if because the work is the force times the distance along the path. There's never any force along the path. The component of the force along the path times the distance traveled along the path, and so there's never any work done on it. That means the kinetic energies should never change, and that means the speed should never change. So I want to calculate the speed, which will be in the first line. It'll be E8, this value. Well, actually, I'll go ahead and do it. We'll just call this the magnitude of the velocity of the particle, and it's equal to the square root of Vx squared plus Vy squared. Should start out at 12. Let's see what we got. Okay, I want to see if this thing is changing. If it's changing, then it's indicating that there's a mistake. If it's not, well, it's not proof that everything is okay, but indicates that, gives me a little bit more confidence in our result. So I went too far with that. Let's put that in there. Look at that, 11.9994. That's essentially 12. I want to widen that column so we can see everything in it. So I would say, sliding up here, our speed is not changing, so that suggests that something's going right. So it looks like, it gets outside the box right there. I can make this a little bit smaller time interval. Let's go 09, and that looks like the one I want to use. So it gets outside the box at about that point. That would be the trajectory until it leaves the box.